Okay, very good.
Okay.
Well, good
Am I audible?
evening.
Yes, sir. Am I audible? Okay, okay. So, warm good morning to Dr. Jeff and very good evening to the participants. Wings of Aero team welcomes you all to this lecture on Earth observations from space. The lecture is going to be delivered by a very experienced and internationally recognized Dr. Jeff Puschell. Prior we proceed towards the lecture, I would like to give a short introduction of Dr. Jeff. Well, talking about his education, he has bachelor's degree in physics from University of Chicago and PhD in astrophysics from University of Minnesota. After receiving his doctorate, he has worked as principal investigator, program manager, chief engineer, chief scientist, technical director, or co-investigator on different government as well as private industries. This includes being chairperson and regional director at American Institute of Aeronautics and Astronautics that we know about AIAA, and he is currently working at Raytheon Space and Airborne System as Principal Engineering Fellow. In their Principal Fellowship Award statement, Raytheon's executive management described Dr. Jeff as one of the world's leading space-based remote sensing systems engineers. He is currently on post of principal investigator for the NASA-funded Advanced Technology Land Imaging Spectroradiometer prototype development, a next-generation land imager suitable for small satellites. Uh, I cannot narrate the whole life of such experienced person, so I will now let Dr. Jeff to lead the meeting. Thank you, sir, and over to you.
Well, thank you very much for that kind introduction. Uh, Good evening to you in India, and Happy New Year from my home office near Solvang, California, about 200 kilometers northwest of Los Angeles. I'm especially happy to be joining you in part because I have deep personal connections with India and people who came to the U.S. from India. And so I'm very happy to be with you today. My talk is about Earth observations from space. And I hope you can see my screen. The cover sheet shows a view of the Earth taken with an instrument called VIIRS. One of the instruments that I've worked on over the years. It's produced at Raytheon. It's in a so-called polar sun synchronous orbit at an altitude of about 833 kilometers. It covers the entire Earth twice a day. And imagery from VIIRS doesn't really look exactly like what you see here. This is a highly processed collection of swaths of the Earth. The swath is about 3,000 kilometers wide, covers the Earth in 14 orbits. And what NASA did was stitch many of those swaths together to form this really beautiful image looking from almost directly above the North Pole of the Earth. Toward the bottom of the disk, you can see India. But it's a very interesting view, I think, of the Earth. And it really captures much of what we can do today from space, collecting imagery, processing it in ways that benefit many different applications. And we'll talk about some of those today. Okay, assuming I can get the slide to advance. Here we go. So I think it's fair to say that observing the Earth from space has really changed the way we see our world. And technology that continues to emerge that really is being developed for many other applications, including observational astrophysics, is really benefiting what we do from space. This is really a collection of frames taken, by instruments built by Raytheon and instruments that I've been associated with as well. And so in the upper left are a couple of frames taken by MODIS. MODIS is also in a polar sun synchronous orbit. It's at a lower altitude than VIIRS, about 700 kilometers versus 833 for VIIRS. The very upper left shows forest fires in the Shenandoah Mountains of the eastern US in the so-called Appalachian Mountains. And if you look closely, you can see the smoke from the fires, but you can also see some red spots or areas indicating the actual location of the fire. So these are multispectral frames combining infrared data showing where the fires themselves are located, and then visible near infrared data showing the plumes of smoke. Just below that is a frame taken near Saudi Arabia, south of Iran, to the west of Pakistan, showing dust storms coming off of the Saudi Arabian peninsula. And instruments like MODIS and VIIRS and many others are very good at detecting events like that. Just to the right is one of the so-called blue marbles taken by VIIRS. So over the years, over the decades, really, NASA has created a whole series of blue marbles, black marbles, and other marbles that really are intended to illustrate applications of Earth remote sensing and imaging from space. And this one is similar to what I had in the cover sheet, obviously from a different point of view, showing the continental US, Pacific Ocean primarily, and again, a very beautiful way of rendering the Earth. To the right, another MODIS frame actually showing a storm at about this time of year moving across Western Europe. Just below is a frame taken from a geostationary imager called JAMI, the Japanese Advanced Meteorological Imager. Now, one of the interesting things about JAMI is that it was a multifunctional, it was on board a multifunctional satellite, MTSat, which is it was actually for the primarily for the transportation ministry of Japan. But what's interesting about MTSat is that it's very similar to INSAT. I mean, Indians were very important in pioneering geostationary satellite technology for weather, communication, for multifunctions. And those satellites, those early satellites were made by an American company known as Ford Aerospace at the time, but later known as Loral, Space Systems Loral. And today they're part of another company called Maxar. MTSat flew in the early 2000s. It was decommissioned roughly 5 years ago. And what you're seeing is a typhoon moving toward the Philippines. And you'll see this video again later in the talk. Finally, to the left is one of the so-called black marbles. And you can see why it's called the black marble, because it shows the Earth at night. And this was also formed by combining together different swaths of VIIRS data. VIIRS includes something called the day-night band, which is a very wide dynamic range imaging band. We're going to talk quite a bit about that today. But you can see the lights at night, and we're coming up on India again. And you'll see much more detail on this later in the talk. So I think it's fair to say that Earth observations from space do give us a different perspective on things and really help define our understanding of where we fit into a much bigger picture. And probably the best example of that is a photograph actually taken a bit more than 32 years ago on Christmas Eve in 1968 by one of the Apollo astronauts. And this was a very important mission. Some would argue that this particular Apollo mission was at least as important as the first moon landing, in part because it demonstrated the technology needed to actually execute that landing. And of course, this shows the Earth floating, as almost an island of life, of civilization, of everything that we treasure on our planet above the surface of the moon, shown from a distance. And